Hi friends, welcome to yet another SDC conference. Today we will be discussing on container storage observability. We will try to cover what is observability and what is the current state, why it is important, and what are the challenges, and what are some of our thoughts going forward to build an open source solution for container storage observability. Myself, Sanil Kumar, I work with Huawei Technologies and part of Soda Foundation, playing as a TOC co-chair there. Let's get into the topic. So before we get into container storage observability or observability, let's try to understand why container application deployments are very important. If you see on the right hand side, you can see some of the industry survey talk about how application container market or container as a service or overall installed base of container deployments and the real usage in production, how the trend is shaping up in the coming years. It is exponentially growing, and the inclination towards container based application deployment is becoming very predominant. It's not a notion anymore. And from Soda Foundation, we also have done a data and storage survey last year. That survey also reconfirms the rapid transition from VMs to containers, and also prominent application platform usage from Kubernetes based solutions, be it cloud or hybrid, or even in the case of on-premise. And many of the organizations, they started using container or primarily Kubernetes based solutions in their real use case deployments. And large distributed container storage deployments are happening. Initially, it started with this very small scale, but the scale is growing. So when you say container application deployments are growing, that indicates that the need for seamless orchestration, provisioning, management of container storage is also becoming very important. That is the context in which we are talking about the observability today. Observability. So we start with what is observability, how it gives the insights to the system. So before we get into the observability part, let's see what is monitoring, because many times observability and monitoring are kind of overlapping. And if you see the word, the specific meaning in English dictionary of monitor or monitoring, it starts with observe. Okay, so there is a significant chance for a confusion. So let's understand both monitoring and observability are same or different. Okay, so monitoring is collecting specific or predefined system information. In the sense, it's something like you are given with a task, okay, do this, and now in between I come and check that, hey, whether it is completed or not, where you have reached, kind of things. So we need to ask that, okay, whether the threshold is crossed or not, and kind of stuff for a specific set of attributes or metrics or resource information, or so and so forth. So it is something like watching a system for specific system information, and based on that you will have some configuration, whether it is cross that or this, and then take some actions, or including analysis if you do. So we try to do known unknowns, in the sense known parameters. When it reaches unknown territories, you take an action, right? That's the way the monitoring works in general. Now, how about observability? So observability, it's mainly based on the output of the system. Describe the system completely. It's not that it is not a very uh, set of parameters. Rather, it takes all the outputs possible in the system from the system, and then try to describe the states and behavior of the system. So when we say a system is observable, every possible state and control vectors, this is thanks to Wikipedia. uh, See, observability is not a very new term. It is new with respect to the computing, or even DevOps or AIOps kind of scenario. It's new, and a lot of research happening uh, today. We will see in the subsequent slides. But observability as a mathematical term for understanding a system is not very new. So if a system is observable, then all possible evolution or change of state and control vectors. The current state can be estimated using only the information from the output. There is nothing else required. So you just observe the outputs of the system, and then you will be able to correctly determine the behavior of the system. And it can give more insights into the system behavior. We'll see more details about this so that we can contrast observability from monitoring very clearly. So derive the behavior of the system. It is something like this, that you have the system is running, and system comes back and say that, okay, my state has changed from this to that, and something like that. When you read the output, based on the output, you can understand that. So this is something like unknown unknowns. Means, in the sense, you are not defining a particular, say, bandwidth, IO, and stuff like that, and then you see whether it is crossing the limits or not. There are a lot of unknown parameters. It will come and tell you whether it is behaving differently or not. So we are talking about unknown unknowns in observability, and it gives more insights than collecting just the metrics or the log or the traces information in the case of monitoring. Now let's understand a bit more. So effective observability depends on how well the internal states are inferred from the external outputs. So as we saw, we are trying to observe the system completely based on the outputs and infer the behavior of the system. Now, when you say the observability, observability is effective, that means the internal states are inferred correctly, on time, from the external outputs. So the key information or outputs generally we see is metrics, logs, and tracing. So generally it is called 3 pillars of observability. Don't worry about that. It's not limited to this. Metrics, logs, tracing are standard information available from any of the systems, but it does not mean that limited to this. Any other information, any other output which can be provided by the system can be utilized to infer the behavior. Anything which can attribute to the behavior of the system, all such information we can use it for effective observability. That's what I have just mentioned, all the outputs, to get the deeper and deeper insights to the system. So I try to give some illustration like I mentioned. So the monitoring case is monitoring some metrics, and once it crosses threshold, give alerts and stuff like that. The same in the case of observability. The cardinality of metrics, in the sense the kind of number of samples or something, it is unlimited. It's not even hundreds or thousands, it's unlimited. All information you collect, and then build that deeper insights, not just particular set. Okay. Now, observability helps for dynamic determination of entire system behavior. It's not very static. It is not for a set attributes. And this is very important when it comes to container storage observability. We'll see that. So observability gives end-to-end deeper performance bottlenecks and insights, as we saw that it tries to infer all the information available to provide deeper insights. And it uses also all the states and patterns, and it helps faster identification of issues and optimize it compared to monitoring. Even there is a state of observability kind of a report which talks about 60% kind of mean time to repair improvement once you move more towards observability than monitoring. So it's faster identification, and it's effective, cost effective repair of the system. And it is sorry, it's very much suitable for dynamic and complex systems like distributed cloud native systems or distributed microservices, because it's very complex. You can't predict all the attributes of the system based on the number of microservices, the behavior of the microservices, when it is up, when it is down. All these things can be very dynamic when it comes to this kind of deployments or modern applications. And with real-time deeper system behavior insights, support effective automation of resolution. Another point is that how well you can automate. You get the information, you infer the information, and based on that information, what all the actions you need to take. So how effectively you can automate the solution. So all these are ideal cases. So when you have an ideal or perfect observability system, this happens, but not in the real situation today. That's what we will see. So, so in monitoring, like we saw, usually we pre-configure and you anticipate possible issues. But in cloud native distributed complex systems, you are not sure what kind of problems that can arise, and you need all possible insights to get some kind of unknowns. Now, why it is important? Okay, so we start from the last point which we mentioned about cloud native applications or microservice or distributed kind of an applications, or even the modern applications. It's very hard to anticipate the type of issues. So we need a better system to get deeper insights. Another key point is that the complex pipelines of DevOps and AIOps, so artificial intelligence for IT operations and management, it needs beyond the predefined data monitoring for a smooth IT operation and management. So AIOps is one of the key consumers of observability solutions to manage the infrastructure. And effective observability can discover new issues, new system behavior continuously and automatically. So this is very critical for service quality, customer experience, and hence the business continuity. Even for business continuity, I think that report talks about some significant improvement when we move more towards observability than just the monitoring and the traditional way of analyzing the anomalies. And it also enable the SREs teams for more secure and resilient software deployments. The first time, or the early the better, when you provide a software deployment that it's secure or resilient. And effective resource management in highly scalable systems like multi-cluster Kubernetes deployments. The effective resource management, that's where you see traditional bare metal to VM to container. The key motto is that one of the key aspects is how well you can utilize the resources, be it compute, network, or storage, how well you can use it. So that in turn influence the cost effectiveness of your solutions. So observability is important to make cost effective, secure, resilient software solutions. Now, it doesn't come free. It has got a lot of challenges, because we talk about a perfect observability system, how it works and things like that. But what are the key challenges? Why we don't have a perfect observability solution, even in commercial or in open source? The major reason is that source silos, because the source of the information is very, very important. So especially when you talk about distributed applications with microservices deployed, everywhere, then building single source of truth is very hard, because there are a lot of inputs and services to services, cluster to cluster. You get different kind of information, and all those data you need to analyze, whether it can be topology, controllers, network, storage, and so on and so forth. And even application specific kind of data, because every application will have different kind of behavior. So this is one critical challenge when it comes to effective observability solution building. And most of these systems, what we are talking about, it is not designed to make the observability working. So observability system design is it is not observable system design or observable system design is one of the challenges. So when we make new systems, we should make it observable. The design should take care of like instrumentation or whatever attributes needed to make the system observable, so that we can infer data from the output itself, the right logs, right traces, and other needed system attributes, so that we can infer correctly and faster. This is one challenge, and all the legacy systems, it may not be available. So this is a challenge, because there are a lot of legacy systems deployed today. Too many tools. We will see in the subsequent slides. There are so many tools for monitoring, because in a way monitoring is part of observability. See, monitoring is the data collection part majorly, and that part is inherent part of observability. There are a lot of tools to debug, trace, log analysis, and so on and so forth. It's in a way good, and at the same time it's bad, because too many tools to manage to infer the data, and most of the tools are incompatible with each other. The outputs generated from the tools are not compatible with each other. This creates very, very hard to infer the dependency of the data or understand the data to bring the right insights of the behavior of the system. And then huge volume, this is obvious. And unstructured data, you might have already started hearing about unstructured data a lot last 2-3 years, the processing of unstructured data. Now most of the processing demand is on the unstructured data, and also the variety, velocity, and complexity of the data are very dynamic, especially for most of the modern applications. So these are some of the key challenges. We'll see some more challenges, especially on container storage observability when it comes to. So this is a basic introduction about observability and why it's important, and kind of challenges what we tend to face. Now, what is the goal? The goal is that we want effective end-to-end observability, where we need a single source of truth. It's not necessary that a single source of data, but all the data, but it is pipelined as a single source of truth, so that the inference can be faster and bring consolidation of distributed and scattered data source through the single source of truth interfaces. Unified observability tools, because we need tools which can co-work or interwork, or some kind of unified way to understand the data, and then write AI/ML modules and 100% automation. So we need to because as I mentioned, it's primarily used for AI ops, then to automate, infer the system, I mean, understand the behavior of the system through artificial intelligence on all the infrastructure management, then we need to be able to use the right algorithmic and predictive mechanisms from AI/ML modules, so that we can do 100% automation on inference and predictive analysis and actions. This is our goal. Now, we will just look into container storage observability. What is the current situation and what we can do about it. Okay, so cloud native project landscape for observability and analysis is growing. Okay, it's not just I'm telling, show you. If you go and see the landscape of CNCF project, this I am only showing the CNCF project landscape. Similarly, you can have a lot of other open source projects, even from Apache Foundation or any other foundations, or I mean independent open source projects. There are a lot of projects for observability or related to observability or in the space of monitoring. Now, if you see CNCF, this landscape will show you both commercial and open source projects. Now, if you see observability and analysis section of landscape of CNCF projects, cloud native cloud computing foundation. Monitoring itself, these are some of the projects available. There are many projects. Each project will have its own use cases, capability, and there will be a lot of overlap. That's what one of the points which we discussed, that too many tools. And some of this blue square which is visible, the boundary is visible, these are some of the projects which are sandboxed or part of the CNCF itself, like OpenMetrics, Thanos. These are some of the popular projects, and the one of the top projects used is Prometheus. These are all for the monitoring purposes. So like we discussed, observability and analysis will have monitoring part of it, then tracing, logging, and different aspects are there. Each category, there are different sets of projects. So in CNCF monitoring, these are the projects. Now it comes to logging, there are so many logging projects available. Fluentd is one of the open source projects which is part of the CNCF landscape, CNCF incubated projects. And similarly for tracing, there are so many Jaeger, OpenTelemetry. OpenTelemetry is one of the projects which is used as a base for most of the telemetry solutions, third party or open source. And there are solutions for visualization. I think visualizations like Grafana. Grafana, different kinds of tools and tool sets are available for Grafana for effective unified visualizations. And chaos engineering is one of the new areas where there are toolkits to have debugging, tracing, and find out the faults in advance. And there are projects for continuous optimization of the data churned, like you can see Turbonomic. This is a project which is acquired by IBM, and there is a Cube Turbo project also to, I mean, work with Turbonomic to get the metrics or statistic data from the system. So why I showed this is that this indicates the current state of observability, especially in the container space. I'm not telling all these projects are for container storage monitoring. Some of them will support. In container storage observability, we have more challenges because all these tools, most of them may not support the container storage monitoring. It's a system monitoring. And most of the container storage monitoring has to go through the CSA interface. We'll see in the subsequent slide. That's a major one of the challenges which we will have. So all these tools are for container observability, container application deployment environment. You can have the observability solution using mix and match of these tools based on the use case. So the pointer is that large number of projects are getting into CNCF observability and analysis. It is growing. open source and proprietary both. And this indicates the criticality of observability challenges and opportunities. So a challenge, as I mentioned, there are too many tools, overlapping tools. So you can get further details from this landscape link. Now, other than this, in Kubernetes deployments, CSI, the container storage interface, it's a specification, and based on that specification, all the storage vendors to write the plugins to the storage vendors to write storage plugins to co-work with Kubernetes, so that all the storage orchestration can happen through the CSI interface, landing onto the CSI plugins of the storage vendors. In storage, in CSI, there is a volume health monitoring feature available for the PVs. So it provides PV metrics, very basic information, in fact, but at least it gives some kind of abnormal volume conditions, underlying storage systems of the underlying storage system, wherever, I mean, whether it is vendor 1, vendor 2, vendor 3, I mean, they will have their own plugins compliant to CSI, so that it can provide these health monitoring information, and it can in turn connect to Prometheus and Grafana to visualize. But this CSI interface today it provides very minimum storage information. Okay. Now, other than that, cloud native and Kubernetes, other than that, cloud vendors provide specific tools. Okay, I have 13 minutes. Okay, I'll go a little faster. So cloud vendors provide specific tools like AWS, GCP. They provide their own monitoring and observability solutions for their own storage, like Azure Blobs, CloudWatch from AWS or GCP. So just this, I have given some examples. Most of the cloud vendors, they have their own solutions like this, and also they provide some kind of an integration with open source solutions like Prometheus, for Grafana for visualization, and for effective telemetry with open telemetry and so on and so forth. And how about storage vendors? They also strive to give more effective solutions for storage monitoring and observability. What they do is that they have their own solutions, and also they partner with open source and commercial partners to build some solutions. Some of the examples I have given on the right hand side, like IBM Terminomic and Portworx solution with the Datadog, and Delhi EMC, there is an open source project for container storage modules. The project is called Karavi Observability, and not limited to this, all the storage vendors will have CSI plugin, and CSI plugin will support that volume health monitoring. So one or the other way, some of the storage monitoring is supported, and whatever is not supported in CSI, we have to depend on the vendor platform. I mean, that is another challenge which we need to get away with. And there are, not only this, there are researchers for smarter observability solutions. So some of the papers I have given. These are all some of my, I mean, I just came across during my reading and Googling. There are a lot of, these are all some of the recent researches happening in observability area, and AIOps, as you know, it's very, very hot, and observability is one of the foundation pieces of AIOps. So what this indicates is that container observability is very, very important. It's critical. If it is not critical, I think there will not be too much of research. Storage vendors, cloud vendors, and cloud native projects will not come to address these problems. Now, the challenges, we have a lot of challenges to bring a comprehensive container storage observability. Some of them are complex distributed dynamic application deployment in container environment. It's not very easy to get all the system information. And application aware storage performance, like I mentioned, application has got different attributes which affects the system behavior. And data silos, too many tools around this we have already discussed, and very limited support from CSI. This is another key point, because CSI supports very limited solution for the observability. So it is so we don't have native solution in Kubernetes or the container space. And heterogeneous and distributed storage support, as you know, we want to support any data center you take. customers would want to go beyond one vendor. So there will be heterogeneous storage and hybrid monitoring, because today most of the solutions are hybrid, cloud, edge, or on-premise. So these are all things makes it more complex. And unified monitoring and visualization across storage infrastructure, because incompatible vendor tools or Kubernetes native tools, because CSI and the vendor tools may not work together. And lack of AML integrations, legacy storages are complex. I think it's out of our even it's very hard for us to bring these observability aspects to the legacy storage. And varied system information, it can be various kind of resources, storage, network topology, controllers, etc., alert management or performance metrics, so on and so forth. So many tools, solutions, research are there in the space of observability, but still we have a lot of challenges and gaps to be filled to get our goals, end-to-end effective observability. So we have challenges. That means we have great opportunity. So container storage observability is critical trend. Summary: research and development are growing and many solutions are available, and it lacks native Kubernetes or container orchestration engine based comprehensive insights and very critical challenges. It is not driven mature today. So huge business potential and opportunity, because the trend is strong and there are challenges. It just started, so it's a very good opportunity. So we are at the beginning of the roller coaster. So till we get there, a lot of opportunity. So we started working on certain things. Something is getting cooked in sort of foundation for heterogeneous storage to container observability. So one of the projects which is already available for heterogeneous storage monitoring is SODA Delfin, which is already you can deploy in products. So it supports resource monitoring for storage, port, network controllers, performance monitoring. We have a unified interface which can support multiple storage vendor devices, alert management, even centralized manager to support different vendor platforms as well. We can talk to the vendor platform to get the data. And driver manager, easy integration of new drivers. And plugin manager will help you to connect to different third-party clients to process the monitored data from the underlying storages. Like you can pipeline to Kafka for AI analysis, the predictive analysis, or it can be pipelined to Prometheus, to Grafana, to better visualization, or even you can use it for your custom client. And it's completely microservice based. And recently we have also deployed the same thing. It is not natively, but it is deployed in Kubernetes. With the Delfin storage drivers, we can actually get the monitoring data even in the Kubernetes environment. But this is mostly on enterprise, and you need custom drivers. It's not native to Kubernetes. So what we want to do is that we want to build this solution as a unified Kubernetes native observability solution, bring Delfin in Kubernetes environment as a native solution. Probably operators and controllers will be a way forward. That's what we are considering. And also complement the CSI monitoring data. So we should be able to work seamlessly with the CSI, because we already have some experience working in unified CSI in SODA, and also work with the storage vendor solutions, or directly communicate with the storage to get the data. So it will be a transition period. CSI plus the storage information combined together, we can provide all the system output information to do an effective observability, and then connect to on the north side to Prometheus or customer. I mean that we already have the Kafka or AML processing or any other third-party tools. This can provide an integrated unified native Kubernetes solution. Some of the use cases I have mentioned here: heterogeneous, unified visualization, storage analysis for predictive analysis, hybrid case to be handled. And some of the key highlights are cloud native ready, microservice based, and unified across heterogeneous storage vendors, and multiple CSI can be supported at the same time. exporters, agent model to complement CSI and the storage attributes. And some of the extended features we could actually research is the federation support, multi-cluster, beyond multi-cluster, federation support, performance, cloud, edge, and distributed observability, and some kind of marketplace for tools which are can be just drag and drop and integrate to this kind of framework, so that the large space of tools also can be managed seamlessly with this framework. These are some of the thoughts, and we just started just deploying into Kubernetes. It's working fine, and now we will start thinking on how to make it more native using operators and controllers under Soda CDM project. Soda CDM is container data management. We already started data protection project. I think the previous session was talking about Soda container data protection part, and next we plan to continue the observability with the Delfin to provide this unified native Kubernetes observability framework. And please join us. This is the right time. Right time is the now. Now is the right time to join. And it's completely open source, community driven project. And we plan to collaborate, or we are already collaborating with CNCF, Linux Foundation, and even the CSI storage stack for effective communication. And we don't want to reinvent things, and collaborate and reuse whatever is available. And we welcome developers of all levels. Even if you are a beginner, please join our Slack, say hi in the Soda CDM channel, and that's where you go. And our maintainers and the team members will be helping you to onboard and give you more information through our community meeting and design meetings. And we can get started and build probably one of the de facto tools for cloud native storage observability solution for Kubernetes. That's all for today. Thank you so much for listening, and wish you a very interesting conference sessions ahead. Thank you so much. This is a Soda Foundation link, and I have also put the references link, whatever I have read while preparing this, which may be useful. Some of the books also I have just put, which may be useful for you. Thank you so much, and have a nice time. Bye-bye.